Algebra 2 Cram, New York State, Algebra 2 Regents. But no worries, this is a Common Core Cram session, so it can be used for any Algebra 2 course throughout the United States. Shout out to Florida, Cali, Texas, I see you. Oh yeah, and it can also be used for any Algebra 2 course throughout the world. Shout out to the UK and Jamaica. All right, functions. Question number 3. Domain of a function. Interval notation. The odds of someone doing exactly what you tell them to do is slim, but I guarantee that if you cram with me, you'll become an Algebra 2 master. If I could stick every single Algebra 2 student with a syringe containing a healthy dose of eye-opening awareness of their inner mathematical genius, I definitely would. So inbox me at memedicine@gmail.com to get your healthy boost by ordering the complete Algebra 2 cram session. You have lots of friends, peers, classmates, or even possibly colleagues who are taking Algebra 2 along with you, so tell them to inbox me at memedicine@gmail.com so that they too can order the complete cram session. Question 3, domain of a function. What is the domain of the function? This is my shorthand for function. I'm not sure if this will fly as actual legit jargon in the world of Algebra 2, so I advise you never to write function like this. So the domain of the function h of x is equivalent to the square root. Usually within the realm of algebra and algebra 2, you don't see the index written when it's 2. It's just automatically understood that you're taking the second root and the index is 2 without this, but here I'm doing it for conceptual purpose that we'll discuss shortly. So the square root, or the second root, of x squared minus 4x minus 5 is going to be a. OMG, you're probably looking like this, like WTF. Well, this is interval notation, and I'm really excited about it to introduce it to those of you who are not familiar. In the context of algebra, an interval is all the real numbers between two given numbers, okay? And when I say real numbers, I mean integers. Integers are counting numbers such as 0, 1, 2, 3, 4, 100, negative 100, negative 2, negative 10, okay? All the numbers that you'll find on a number line. Real numbers also include rational numbers. Rational numbers can be expressed as fractions, and when you simplify the fraction, the decimal will either terminate or repeat. Last but not least, real numbers also include irrational numbers, numbers that can't be expressed as fractions because when you simplify them, the decimal will not terminate or it will never repeat. Examples of irrational numbers are the number pi, which we usually brief and shorten as 3.14. Also, you have Euler's number, or the natural number e, which is approximately 2.71, as well as the square root of 2, which never terminates or repeats according to, recorded mathematical knowledge. All right, and so in interval notation, we write the beginning and ending numbers of an interval, and we usually use square brackets to include the end value, or we'll use a round bracket when we don't want to include the end value, okay? And we use this U-shaped cup, and it means union, or the joining together of two intervals, or the joining together of two sets. You'll be familiar with that word sets if you watched the previous Cram session, okay? So I'm going to take a shot at this and say this in a way that will fly in your Algebra 2 course. So this means the interval from negative infinity to 5 do not include infinity, but do include 5, union the interval from 1 to infinity, do include 1, but do not include infinity. Or is it going to be b, the interval from negative infinity to negative 1, do not include negative infinity, but do include 1, union the interval from 5 to infinity, include 5, but do not include infinity? Or is it going to be C, the interval from -1 to 5 inclusive? Or D, the interval from -5 to 1 inclusive? Okay, so definitely press pause to think about and come up with the correct answer choice if you haven't already in your mind. I know when I was first learning this, it took me a long time, so take your time, but don't take forever. You know, life is all about expediency now, okay? So we need to learn shortcuts or, you know, expedite getting things done. Alrighty, so I hope you came up with an answer for the domain, and if not, that's definitely okay. The domain of a function is defined as all the x values where the graph exists. If a domain is not given, it's assumed to be the largest set of real numbers. Remember, we just discussed real numbers for which the output of the function, that's the y value or dependent variable, is defined and real. We just discussed what real numbers are, okay? This means that there are going to be a few criterion for determining the domain of a function, all right? Criterion A, and this is in no particular order, radicands. When I say radicands, I mean the expression underneath the radical sign. So radicands with an even index. This is why I put the number 2 here, because it's an even index radical. It could also be 4, 6, 100, you name it, must be greater than or equal to 0. So the radicand underneath the radical sign with an even index must be greater than or equal to 0. This greater than or equal to 0 is referring to the radicand, okay? The second criterion is that if you do have a denominator, if you're dealing with a fraction, then the denominator must not be equal to 0 because division by 0 is undefined. And the third criterion, or criterion C if you prefer an alpha numbering system, that even makes sense, is that the arguments of logs, okay? When I say argument, I mean that what you're taking the log of, which is called an argument, a power, or a result. So the arguments of logs must be greater than 0, okay? Because let's say that you do take the log of 0, the log of 0 is undefined, and if it's less than 0, the log of an imaginary argument, well, the log of a negative number is imaginary. And at this point on your journey in math, if you're just at the Algebra 2 point, maybe you're not, maybe you're beyond this, but for those of you who are, we're not ready for the realm of imaginary polar coordinate planes just yet, okay? That comes a little later. If you venture that deep into mathematics in your education and career. So in this problem, only the first criterion, or criterion A, is going to be relevant. So we're going to proceed with this notion that this radicand must be greater than or equivalent to 0, okay? And we're going to solve this algebraically. Well, we're solving it algebraically because we're trying to determine the answer for the interval. What we're going to have to do next is we're going to have to find the roots of equality. We're going to treat it just like a regular polynomial. So we're replacing that inequality sign with an equal to sign just for the purpose of temporarily finding the roots. So this is the part of algebra that gets a little hairy because, you know, we're used to very precise, neat guidelines in math. But in algebra, you can kind of play with things a little bit. And some manipulation is legit and some isn't. This is one of the things that you can do in setting up interval notation, okay? Although you're given a greater than or equal to sign, just to find the end values or beginning values for the interval, you can exchange that inequality for the equal sign to set up the roots. So we're looking, if you treat this like a normal polynomial, we're looking for two numbers that when multiplied will yield will yield 5, but when you add, you'll get -4. And the first numbers that come to my mind are -5 and 1. So x times -5, x minus 5 times x plus 1 is equivalent to 0. This is the backwards reverse FOIL method, okay? All right, and yeah, so now according to the zero product property, which says that the product of two factors, if it's equivalent to 0, either of them can be equal to 0 or both can. So that's why we always arrive at this in our point of solving for the roots of polynomials. So we have that x minus 5 is equivalent to 0, or we're not saying and, we're saying or x plus 1 is equivalent to 0. Okay? Now, this means that our root can either be 5 or x is equivalent to -1. Okay? Hopefully you're not worn out mentally. We have a little bit more to go, not too much. We can then graph these endpoints on a number line to try to establish our interval, okay? And number lines are great ways to visualize an interval. So here we have our -1, x equals -1. And notice that a filled in circle is when we want to include our end value because we're told that x can equal this in order to get a value of 0. And this covers the equal portion of the inequality because the function can in fact be equal to 0. So we don't have to go back and plug this in to check, whether or not it's going to work out. We're told that one of the options is that this polynomial can be equal to 0, so that's why our endpoints are filled in or our roots are filled in. And then we also fill in a circle at 5. Okay, so the next step in our process is to check values from one of the 3 intervals on our number line. Okay, so the first, in interval 1, in the realm of negativity, we're going to check -2. We're going to plug -2 back into our original inequality, all right? So -2 squared is going to give us 4, minus a -8, that's going to give us 12, minus 5 is going to give us 7, and we get that 7 is greater than or equal to 0. Well, this in fact is a true statement. So this portion or interval is going to be included in our final result. Now we're going to check something from the middle ground, the middle interval. We're going to plug in 0. So 0 squared is 0, minus 4 times 0 is still 0, minus 5, well, this is going to yield -5 is greater than or equal to 0. This is in fact not a true statement, therefore this interval will not be included in our final interval notation, okay, for the domain. And last but not least, we're going to check something from the realm of positivity, specifically 6. So when x is equivalent to 6, we have 6 squared is 36, minus 4 times 6. Well, 4 times 6 is going to be 24. 24 minus 30, subtracted from 36 is going to yield 12. 12 minus 5, that's going to yield 7. And we have again that 7 is greater than or equivalent to 0. Well, this is in fact true. So now we just basically shade in our regions that are accurate. So this interval is going to be included. this is not included. So basically the guideline, when an interval on a number line is included, you shade it in. You thicken or you make the line bold. This line is thin, it's not included. This point and line are both included, okay? So as an inequality statement, this can be translated into this. The domain of x such that x is less than or equivalent to 1 or greater than or equivalent to 5. So we have two intervals here that we need to account for in the domain, okay? And expressed as an inequality, this translates into answer choice B. All right, so we're going to read this. The interval from infinity or from -1 to infinity do not include infinity, but do include -1. Union, the interval from 5 to infinity, do include 5, but do not include infinity. Okay, so again, the correct choice is answer choice B. And the original function could have also been plugged into our graphing calculator and graph so that we could determine the correct interval. So in your y equals equation editor, we simply input the square root, which is going to be second x squared of x squared minus 4x minus 5. And then before heading to the graph visualization feature, if you were to basically try to open up the table, you would see that you get various ordered pairs. And at 1, or at -1 rather, you get a value of 0, which we know is true because we determined that 1 was a 0. But you know that middle region that wasn't shaded in, you get an error message. This lets you know that that interval is not included. But then when you come down to 5, this is 5 here in case you can't visualize it, you get 0. And we knew that 5 yielded a result of 0 because we solved our polynomial, okay? And determine the roots. And roots are simply x values where the functions are equivalent to 0. Now, when you graph this, what do you have? You have definition, or the appearance of a graph from -1 less, nothing in the region between -1 and 5, and then you have a graph from 5 up. Okay, thus this also corresponds with answer choice B. Thanks for tuning in. Good luck.